The Bitwarden CLI package on NPM was serving malware. Not potentially vulnerable, not researchers found a theoretical path. Serving, active, malware. If your CI/CD pipeline pulled the NPM package called @bitwarden/CLI in the affected window, you may have already exfiltrated credentials you didn't know you were exfiltrating. Here's what actually happened. Researchers at Socket identified a malicious NPM package impersonating the legitimate Bitwarden CLI. The package name used in the attack is a type-a-squat or namespace confusion variant targeting teams who install Bitwarden's CLI tooling through NPM as part of automated pipelines. This is part of a broader campaign that Checkmarx has been tracking, involving coordinated package poisoning across the NPM ecosystem. The attack isn't novel in technique. Type-a-squatting and dependency confusion have been documented attack vectors for years, but the target is what makes this operationally significant. Bitwarden CLI is not some random utility. It's a secrets retrieval tool. Teams use it specifically to pull passwords, API keys, and service credentials inside CI/CD runners. Compromising it is not like compromising a markdown parser. Compromising it means you potentially handed an attacker every secret your pipeline touches. Let's be precise about the mechanism, because the reporting from most outlets is doing that thing where they describe the attack in vague terms and then move on. The malicious package installs a postinstall script, a standard NPM lifecycle hook, that runs arbitrary code the moment the package is installed. You don't have to execute the CLI. You don't have to call any function. NPM runs that script automatically on install. This is a well-known and frankly embarrassing property of the NPM ecosystem that the community has been arguing about for years without resolving. The postinstall hook exfiltrates environment variables. In a CI/CD context, environment variables are where every secret lives. Your AWS secret access key, your database URL, your GitHub token, your Kubernetes service account tokens, all of it gone before the pipeline even gets to your actual build step. The Checkmarx campaign context matters here. This isn't an isolated incident targeting Bitwarden specifically. Checkmarx has documented a sustained campaign where threat actors publish packages designed to look like popular DevOps and security tooling. The pattern is: find tools that security-conscious teams use, publish near-identical package names, wait for a typo or a copy-paste from a README, collect credentials. Previous targets in similar campaigns have included tools in the HashiCorp ecosystem, cloud CLI wrappers, and infrastructure as code helpers. The attackers are specifically hunting teams that take secrets management seriously, because those teams are the ones with access to the most sensitive systems. Now, what's your actual exposure surface? If you use Bitwarden CLI in CI/CD, the question is how you're installing it. The official Bitwarden CLI is distributed as @bitwarden/CLI under the Bitwarden organization scope on NPM, and also as a standalone binary through GitHub releases. The attack vector here is specifically the NPM package ecosystem. If you're pinning to a specific version hash and you verified that hash against a known good state, you may be okay. But you need to verify that, not assume it. If you're doing npm install g @bitwarden/CLI or pulling it as an unlocked dependency in a pipeline that runs on every PR, you need to audit what was actually installed and when. Check your pipeline logs. Look at the exact package version and the install timestamp. Cross-reference against the Socket and Checkmarx advisories for the specific package names and version ranges flagged as malicious. If you can't reconstruct exactly what was installed, treat the environment as compromised. That's not paranoia, that's the correct incident response posture when the tool that was potentially compromised is a secrets manager. The rotation question is the uncomfortable one. If you have any doubt about whether a malicious post-install script ran in your CI environment, you need to rotate every secret that was present as an environment variable in that runner. All of them. This is painful. It's also non-negotiable. A secret that may have been exfiltrated is a secret that must be treated as exfiltrated. The attacker doesn't announce themselves. You won't get a breach notification. You'll find out when someone uses those credentials, and by then the window for clean remediation is closed. There's a broader architectural point here that this incident illustrates cleanly. Fetching a secrets management tool from a public package registry inside a privileged CI environment is a design smell. The Bitwarden CLI, or any similar tool, should be treated as infrastructure, versioned, hash-pinned, pulled from a controlled artifact store that you manage, not fetched live from npm on every pipeline run. If your pipeline is doing npm install on a security-critical tool at runtime, you've made the public npm registry part of your security perimeter. It isn't. npm does not guarantee package integrity in a way that protects you from this class of attack. They have some controls. Those controls failed here, or at least didn't prevent the malicious package from being available long enough to matter. The secrets in environment variables pattern also deserves scrutiny. It became standard because it's convenient and because tools like 12-factor app normalized it. But environment variables are globally readable within a process. They show up in logs more often than they should, and as this incident shows, a single malicious post-install script can hoover all of them up trivially. If you're running on a platform that supports proper secrets injection, AWS Secrets Manager with IAM roles, GCP Secret Manager with workload identity, HashiCorp Vault with short-lived dynamic credentials, the environment variable as a secrets transport mechanism is worth revisiting. It doesn't eliminate the risk entirely, but it reduces the blast radius when something like this happens. On the Bitwarden side specifically, the legitimate Bitwarden CLI is an open-source project, and the Bitwarden team is not the attacker here. They are a victim of namespace abuse. But this is a moment where they, like every security tooling vendor, should be loudly and clearly telling their users to install from binary releases with verified checksums, rather than treating npm as the primary distribution channel for a security-critical tool. Unclear from the reporting whether Bitwarden has issued explicit guidance on this yet, but if you're a Bitwarden user, don't wait for that guidance. Practically, here's what to do right now. First, audit your pipelines for any npm-based installation of Bitwarden CLI or any other security tooling. Second, check the specific package names and version ranges in the socket advisory. Don't rely on the script to have that list. Go read the primary source. Third, if there's any doubt about a runner's install history, rotate secrets and treat the environment as dirty. Fourth, move security tooling to pinned binaries with SHA-256 verification, stored in your own artifact registry. Fifth, consider whether your CI environment's access to secrets is scoped as tightly as it needs to be. A compromised install step should not have access to production database credentials. The real story here isn't that Bitwarden was hacked. Bitwarden wasn't hacked. The real story is that the npm ecosystem's install time execution model, combined with the difficulty of distinguishing legitimate packages from imposters, makes public package registries a reliable attack surface against exactly the teams that think they're doing secrets management correctly.